Hi grade 12 and welcome. In this video we will be learning about radians measure, area of sectors, the length of the minor arc and the major arc, and these topics are from trigonometry. Now looking at radians measure, areas, arcs and sectors, let's have a look at the circle. In the circle we have some center O. We know these are the radius from the center of the circle to the circumference. Circumference means the outer part of the circle, right? So from the center of the circle to the circumference is a radius, and that's the radius. The central angle we call theta, right? Since the central angle is theta, the entire angle on the outside of theta is 360 minus theta. Don't forget that, right? That's 360 degrees minus theta. Now in radians measure we use a very basic formula. We know we have radians, and we have from radians to degree and back. We just use a simple formula. We say pi radians is approximately pi radians is basically 180 degrees. So for example, if we want to convert 30 degrees to pi, right? If we want to convert 30 degrees to pi, then we're going to put an x on this side, and we know 180 degrees. Let's write it like how I showed you. So if we say pi is, we start off with the formula pi is 180 degrees, and if we want to know what is 30 degrees in pi, so we put the x below the pi, and the best way to do it is just cross multiply and solve, make an equation. So we get x times 180 is 180x, and that's 30 pi, cross multiplication. Now we divide both sides by, we can divide both sides by 180, right? And 180, 180 divided by 180 is x, right? That cancels out. 30 divided by 180, so you can cancel out the zeros, and 3 divided by 18 is pi by 3 can go into 18 6 times, so pi by 6, and we know pi by 6 is basically equal to 30 degrees. That's how we go about solving. Or if you want to use a formula, you can go and use a formula. You can say theta in radians. To convert theta in radians, what did we do? So if you're looking at this, we say theta in degrees, and we can multiply it by pi and divide it by 180. That's what's being done here. So to use the same thing and convert theta in radians to, we have theta in degrees, we want to convert theta in radians, we can say 30 times pi and divided by 180, and use this formula here, and we still get pi by 6. So we know 30 degrees is pi by 6. So I do have more examples that we can look at. Now we want to know what is the area of the sector. To calculate the area of the sector, just try to use theta in degrees. That's the reason why I've shown you this. So to find the area of the sector, we use the formula area is equal to half r squared theta in radians. It has to be theta in radians. Okay, so half r squared theta in radians. So basically what that represents is this piece of slice here, or we can call it a sector. This is the sector of the circle. The distance from here to there between those two radii on the outer end is called the arc length, or we call it the minor arc, right? And minor arc, let me call it S1, and the other side is the major arc. Major arc is the curved distance around here, so that's S2. So the length of the minor arc, we say, is just S1. S1 is equal to r theta. Theta must be in radians. Minor arc is the distance from there to there. So what do? We just take the radius multiplied by the central angle. Next one, what is the length of the major arc? Very simple. The distance around the entire circle is 2 pi r. So we just say 2 pi r minus s1. Right. So in simple, the major arc is equal to 2 pi r minus r times theta in radians. I hope you guys understood all this. So we can just look at these basic formulas. What is required for this section is area of sectors, which is half r squared theta. Arc length, minor arc is r times theta in radians, and the length of the curve length of the major arc is basically 2 pi r minus r theta. Now let's have a look at some of the questions that we can do. What is the radians measure of 30 degrees? Okay, I've solved it before. A radians measure of 30 degrees, we can say theta in radians is equal to theta in degrees times pi over 180. So theta in degrees is 30 pi over 180, and I get pi over 6. Right, so theta in radians is pi by 6. That's 30 degrees. Next, hence find is arc length. So what's the arc length? Arc length with respect to this central angle here, which is 30 degrees. So we are basically trying to find this angle here. We are trying to find this small piece here, the arc length. So we're finding the distance from there to there. So that's S1 with a radius wasn't given here, so radius should be 3. Now looking at the radius 3 here, so hence find is arc length and area of the sector with the central angle pi by 6 and radius 3. So this was not given, it should be given in this problem. So radius is 3, we're going to find the arc length. So S1 is equal to r theta. The r is 3, radius is 3, theta must be in radians, so that's pi by 6, right? And pi by 6, 3 divided by 6 is half. We're getting half pi. Now sometimes for Tahsili exam there's no calculator, so you must know a basic thing. Pi approximation for pi is 3.14. So you're going to say half times 3.14, and I will get 1.57 units. Right, and now to find the area of the sector, we use the formula area is equal to half r squared theta in radians. So we're getting half r squared is 3 squared, theta in radians is pi by 6, that was 30 degrees. So 3 squared is 9 over 2, and multiplying by pi by 6, so right here, and let's see, 9 times 9 pi over 18, 9 pi over 18, 2 times 6 is 12, not 18, 9 pi over 12. So we will get 3/4 pi, because we can divide the top 9 by 3 and the 12 by 3. 9 divided by 3 is 3, 12 divided by 3 is 4, 3/4 pi. And we want to know what's the value of 3/4 pi. So let me just pop my calculator, right? So 3/4 pi, 3 over 4 pi. Shift and pi, we're getting an answer of 2.36 units squared. Or square units. So the final answer is 2.36. Right, you can leave your answer like this or like this. If you are using a calculator, 2.36. Next one. What is the radians measure of 20 degrees? So we have theta in radians, so that's 20 pi over 180. Zeros cancel out, 2 divided by 18 is 9, so 1 over 9 pi or pi over 9. We have pi over 9 radians. We wrote theta in radians, so it's pi over 9. So we have that. Next one, find its arc length. So again, the radius I will put here is 3 because the radius wasn't given. Find the arc length. Arc length is S1 is equal to r theta in radians. What's r? R is 3. Theta in radians is pi over 9. So 3 divided by 3, 9 divided by 3. So pi over 3. Pi over 3 units. Remember, you can put this in the calculator and get the get a decimal value for that. So you're basically taking 3.14 and dividing it by 3. You should get 1,04 something. To find the area of the sector, let me just write area of sector is half r squared theta in radians. So you say half, what's r squared? R squared is 3 squared. Theta in radians, what will theta be in radians? That was pi by 9. Okay, so we need to put pi by 9 here, and we can clearly see that we got 3 squared, which is 9, and the 9 can cancel out, so we just have pi by 2. Final answer. Right, so we must be used to these types of tricks. Pi by 2 units squared. I hope you guys are understanding. You can get a decimal value. Remember, areas are in units squared, distances are in units, and volumes are in units cubed. Next question. Convert an angle of pi by 4 radians to degrees. We know pi by 4 radians, so pi by 4 rad, right, is equal to, we know pi is 180 degrees divided by 4, and 180 divided by 4 is 45. 90 divided by 2, 45 degrees, right? So pi by 4 is basically 45 degrees. Find its arc length and area of sector with the central angle. So over here the radius is 4. It wasn't given, so I'm putting it part of the example. So what is S1? S1 is the length of the minor arc, which is r theta in radians. What's r? R is 4, and theta in radians is pi by 4. We can see the 4 and the 4 cancels out, and we're getting pi, and pi is approximately 3.14. That's the approximation sign, 3.14 units. Next one, to find the area of the sector. Area of the sector is basically half r squared theta in radians. So we got half what's r squared? 4 squared. Remember I said the radius is 4. 4 squared theta in radians is pi by 4. Now half of 16 is 8, right? And 8 divided by 4 is 2. So my answer is just 2 pi. Or you can do it like this: half of 4 squared. 4 squared is 16. So we're getting 8, and we're getting pi by 4 here. And 8 divided by 4, remember that's 8 over 1. So 8 divided by 4 is 2. So we're getting 2 pi, which is approximately 2 times 3.14, 6.28 square units squared. I hope you guys are understanding. Now moving on to the next question, we see that we have question number 4. Convert negative pi by 8, right? Let's convert negative pi by 8. Convert negative pi by 8 in radians to degrees. So negative pi by 8 in radians to degrees. I'm going to give you one more example. We're just going to add one more additional question here. I want to convert 2 radians to degrees. Right. So if I want to convert 2 radians to degrees, I know pi is 180. So 2 is x. If I cross multiply and solve, that's how I will get the degrees, right? So if I cross multiply, I'm getting pi times x, and 2 times 180 is 360, right? So x is equal to 360 over pi. 360 divided by pi, which is approximately equal to how many degrees? 360 over pi. So you're going to take 360 over shift and pi, and we're getting 114.59. 114.59, let's make it 0.6 degrees. So I hope you guys understood that. So 2 radians is approximately 114.6 degrees, and pi is about 3.14 radians, is 180 degrees. Now continuing with our problem here, let's go back to question 4. Negative pi by 8 in radians to degrees. So we know pi is, okay, negative pi by 8, no problem. Negative pi by 8 radians, we know pi is 180 degrees. You can just divide that, so simple, right? So we say negative 180. Remember, we replace pi with 180 because pi is 180 degrees, and you divide it by 8. So 180 degrees divided by 8, you should get 180 divided by 8. I'm getting 22.5, right? So I've got negative 22.5 degrees. Now what does this angle, what does the negative angle tell us about the orientation? So the negative angle says the orientation is what? Which direction is it in, right? So we know if we go in this direction on the diagram, we're going positive theta, right? And when you go down, it is negative theta. When you start from here and you go down, it is negative theta. So negative 22.5 will basically be in the 4th quadrant. So when you're going positive theta, it is anti-clockwise direction, and if you're going negative angle, it is clockwise direction. So you can write the orientation is clockwise. What does this angle indicate about its orientation? Orientation basically means the direction. So you can say the orientation of the negative angle, indicates a clockwise direction. The orientation of the angle is clockwise. Okay, I hope you guys are understanding. Right, moving on to the next question. Now these are simple questions from past Tahsili exam papers. What is the measure of the hour hand from 12 p.m. to 3 p.m. in radians? So looking at the clock, right, we know we have 12, 3, 6, 9. So the hour hand moved from 12 p.m. to 3 p.m. Okay, so what's the angle from 12 to 3? The angle is 90 degrees, and 90 degrees is what? 90 degrees is basically pi by 2. 180 divided by this, pi by 2 radians. So my correct answer over here will be B. Right, so that's the working out for this example here. Next problem. What is the measure of the second hand from? So when we're looking at seconds, we're looking at the last values, right? 30 seconds. So second hand from 12 o'clock to 30 seconds. Okay, so I'm going to draw this. So remember, that's the 60 seconds. Moves there is 30 seconds. No, that will be 15 seconds. Seconds hands, alright? So that's 15 seconds. That's 30 seconds. That's 45, and then you come back to 1 minute. So that's where it's moving. So it started from 60, right, and it's going directly across because we want 30 seconds, goes in this direction. Okay, there's the direction it goes into, and it comes back to 30. So from there to there, what is that angle? It's a straight angle, and that is 180 degrees. I hope you guys are understanding. Right, moving on to the next question. Right, so we're going to make the radius, there's no radius here, so we're going to make the radius 3 as well. Find the arc length and area of the sector if the radius is 3 again. Right, now let's solve this. So the radius is 3. 3 here. The central angle is 60 degrees, alright? I don't want to put 60 degrees. I know 60 degrees is 180 degrees divided by 3, so 180. So theta in radians is equal to, theta in degrees is 60 times pi over 180. That's a formula. Now 60 divided by 180 is 1/3, so pi over 3. So pi over 3 is the radians measure for the central angle. We want to find the length, arc length. When we say arc length, it basically means the minor arc from here to there. So that's pi by 3, the minor arc. So we're looking at the minor arc. So that's S1 is equal to r theta. R is 3 and theta in radians is pi by 3. Okay, so I'm just getting pi units. So that's 3.14. that's approximately equal to 3.4 units. That's the approximation sign. Next one, if we want to find if we want to find the area of the sector, so area of sector is equal to half r squared theta in radians. Half, what's r squared? That's 3 squared. Theta in radians is pi by 3. Right, so we can see that we got 3 squared is 9 over 2 times pi by 3, 9 over 6 pi, multiplying 9 pi over 6, divide by 3, we're getting 3 over 2 pi. Right, you can work this out in the calculator, what is 3 over 2 pi, as I have showed you before, and you can just write down the answer, 3 over 2 pi units squared. Now if you're going to work this out in the calculator, you will get 3 over 2, so 3 over 2 pi, shift the pi, 3 over 2 pi is basically 4.71, so 4.7, approximately 4.7 units squared, and that's the area of the sector. Now remember, we only calculated theta in radians, length of the minor arc. What if we have to calculate the length of the major arc? Very simple. S2 is a major arc, so that's 2 pi r minus S1. What's 2 pi r? 2 pi r is the distance around this entire circle, which is 2 pi times r is 3 minus, what is S1? S1 is pi. So I've got 6 pi minus pi, which is 5 pi units. So that's the distance around. Now 5 pi units, what is 5 pi? 5 times 3.14, an approximation, which is 15.7. So that's approximately 15.7 units. Right, I hope you guys understood this section. If you have any concerns or questions, don't forget to leave comments. Thank you.